All right, welcome back again to my channel. My name is Oluwaseun, and I want to wish you a happy new year. Now, this is the first video that we are going to be releasing, that I am going to be releasing on my channel this year. And I thought to release something that is comprehensive, something that we can learn multiple tools and multiple skill set, all right, in the video. And that is why I have taken my time to come up with a video that basically shows us how to automate the WordPress deployment on AWS. Now, in the previous videos that we have released on the channel, we talked about how to set up, a three-tier web architecture on AWS that can help you to, set up your WordPress installation and all of that. And the architecture that you can see on your screen is also the same architecture that we used in that video. But this time around, I have made some improvements to the architecture, because what we are going to be doing into this video is to set up this whole infrastructure using Terraform. And we're not just going to be using Terraform locally, we're going to be deploying this whole infrastructure through the GitLab CI/CD environment or platform. That is exactly what we're going to be doing. Now, another improvement that we have also made to this is that we are also going to be integrating the EC2 Instance Connect endpoint to access our EC2 instance that will be launched in the private subnet. And the reason why we are doing that is because we do not want to have to manage any form of SSH key at all. So what we want to do is, after we have deployed our instances and all our resources, we want to be able to access our instances via the EC2 Instance Connect endpoint without having to manage any form of SSH key. Now, what I'm going to do is that I'm going to walk you through the Terraform configuration that we are going to use to deploy this whole infrastructure. And of course, I'm going to walk you through the GitLab CI pipeline configuration file that we're also going to be automating the Terraform deployment. Okay, so let's get right into the video. Now, the first thing that I want to show you here, of course, is the architecture that we can see. So let me just walk you through a few things that we have in this architecture that are basically improvements that we have made from the last video. Now, in this video, we have the DynamoDB, which is basically to help us to manage our Terraform state lock. All right, and then we have the IAM role, because our EC2 instance is going to be assuming this role in order to be able to interact with other services like database, like Secret Manager, and of course the EFS. Now we have the Secret Manager. The reason why we are having the Secret Manager in this architecture is that our database that we will be creating using Terraform is going to generate. The reason why we're going to be using Secret Manager in this scenario is because the database that we're going to be creating with our Terraform configuration is going to auto-generate its password and store the same inside of the AWS Secrets Manager. And so we would need to be able to fetch this password from the Secret Manager in order for our WordPress to connect successfully to our database. So the reason why we need the Secrets Manager. Now, let's go over the Terraform configuration that we have here one by one, in order for us to be able to make sense of what we have and what we want to do and how we want to achieve this architecture by automating its deployment through Terraform. Now here, we're going to be using a modular approach, because in Terraform, you can actually create modules, all right, that you want to use to deploy your own infrastructure. And you can also leverage some predefined modules that are already available on the Terraform documentation page. But in our own case, we have decided to create our modules ourselves. Now, if you look at what I have here, I have modules, and I have 1, 2, 3, 4, 5, 6, 7, 8 modules. So we are going to be working through these modules together in order for us to make sense of what each of the module represent and what exactly these modules will be doing. Now, for those who are new here and perhaps this is your first time of coming across maybe Terraform, you really don't know what we're talking about, but let me just give you an understanding of what I just mentioned, which is the Terraform modules. Now, the Terraform modules is a way to basically, the reason why we're using modules in this instance is because we want to group our resources into logical units. Now, we do not want to have all our configuration on a single file. We don't want to put everything inside of the main.tf. So we have decided to break it down into different logical units. So in this case, we have the ALB, which is the application load balancer. So that is a module. We have the ASG, which is also the auto scaling group. That is also a module. We have the EC2, which is also a module of its own, and we have the EFS, which is also another module. We have the EIC, which is the Instance Connect endpoint. We have the network, which is basically the VPC that we created. We have the RDS, which is the database module, and we have the security, which is basically the module that defines all of the security groups that we will need for our deployment. All right. Now, inside of the root module as well, we have the main.tf, we have output, we have Terraform.tf, we have Terraform.tfs, and we have variables.tf. Let's take a look at what each of those modules contain. And of course, we're going to do that based on the architecture that we have on our screen right now. Now, if you look at this architecture, there are, of course, quite a number of resources that we need to create. We need to create a VPC. All right. And then that VPC should have a NAT gateway created, an internet gateway created. Of course, we have to configure route tables and all of that. We have to configure subnets and other necessary things. Now, if we move into the EC2 space, we have to also create an EC2 instance that would basically help us to, set up the whole WordPress environment and just give us that foundation that the auto-scaling group can actually, rely upon and all of that. And then we also have the database. So we need to create a database that the WordPress is going to leverage to store its data and things like that. All right. And of course, we have an IAM rule. That means we also have to create an IAM rule that our EC2 instance will assume, all right, in order to be able to interact with, the database, the EFS, the secret manager, and the rest of other services. Now we have the DynamoDB. Like I said, the DynamoDB's job here is basically to help us to manage the Terraform state lock, so that by the time we are working with Terraform, we are applying our configuration, all right, that session is basically locked, so that any other person that is trying to do something about the same time will not be able to do that, all right, while we have the Terraform apply ongoing. So that is the purpose of the DynamoDB. And of course, we're going to have our S3 bucket that is going to help us to store the state file. All right. So we're going to have all of that as well. Now, if you look at all of these resources, it tells you that we have to create a NAT gateway. We have to create an application load balancer. We have to create an internet gateway. We have to create, quite a number of these resources. And that is why we have separated these resources into logical modules, such that we can understand what each of the module is about and how these resources will be created, which one depends on which one will be created first before the other, and all of that. Now, if you look at what we have here, we have the ALB. So if I expand the ALB, inside of ALB module, we have the main.tf, we have the output.tf, and we have the variables.tf. Now, the ALB module basically is a child module that is responsible for helping us create our application load balance. All right, that is what the ALB is doing for us. Okay, so we need an application load balancer that will serve as the front end that people can access and then be able to reach WordPress installation. All right. Now we have the main.tf, we have the output.tf, and we have the variable.tf. So let's go over to the main.tf. Now, if you look at the main.tf, of course, we have the resource, and all of the things that we have right here are things that you can get on the Terraform documentation page. There are things you can get on the Terraform documentation page. Now, for the purpose of those who may not understand, what I'm saying, we can actually go to the Terraform documentation page right now and take a look at what we have on that page. So here, if you go on the Terraform documentation page, you can search for the provider that you want. So for example, I can click on providers here and I can see that we have a lot of providers. So, but then the provider that we are dealing with is the AWS provider. So I'm going to click on AWS. And right here, if I scroll down, of course, it's going to show me all the modules that are available, all right, for AWS. So there's the VPC module, the S3 bucket, the EKS. I mean, a lot of modules that you can actually use right here out of the box if you do not want to create your own modules, okay? Now, if I click here on the documentation, I can click documentation, and on my left side, I'm going to see all of the AWS services that I can actually create with Terraform. Now, the way Terraform works, for those of us that are new to the old Terraform thing, is that now you have the resource and you have the data block. So the resource block is basically the block where you can specify the resource on AWS that you want to create. So for example, this resource block is basically going to create an AWS VPC, all right, with the CIDR block 10.0.0.0/16. All right. And then we also have the data block. The purpose of the data block, let me see if we can find one here. Let me just go to EC2 right here and just search for that. I mean, I can search right here. So for example, let me just pick one of these things. So let me pick the AMI, for example. Now here I have the resource block. So the resource block here, it's going to help us create an AMI, all right, Amazon machine image. And then if you scroll down, do we have the data block here? We don't have. So let me look for the one that has the data block so that we can understand this thing better. All right, so this is the AWS instance. Now look at that. So here we have the data block. Now the purpose of the data block in Terraform is to allow you to query your AWS environment to fetch, resources, maybe values and things like that. Okay, so when you're using Terraform, there's the resource block, which allows you to create resources. And then there's the data block that allows you to query your AWS environment in order for you to get values, all right, that you can actually now pass in to maybe a resource block session to create something. For example, this data block is going to be querying the AWS environment for AMI, using some filter, as argument and things like that. So whatever AMI that this data block generates for us is now going to be used to what? To create an AWS EC2 instance that actually uses that particular AMI. Is that okay? So here we have the data block. So querying the AWS environment, getting us, all right, an Ubuntu image that, fulfills this particular argument or filter. And then we go into the resource block session and then we use whatever value, all right, the AMI that we got, whatever it is that we get, we use that, all right, and pass that in as the AMI that this resource is going to now use. So by the time this instance is created, the instance is going to be created using this particular AMI. All right, so there's the resource block, there is the data block. Is that okay? So now here in our own configuration, we have the resource block, and the resource block here that we're creating is the name of the provider, all right, the name of the resource that we want to create, and then a logical name of that particular resource. So here we are creating the AWS load balancer, all right, and then the logical name that we have given to this one is what is called main. Now, every resource that you create on AWS has attributes, all right? Now, if you have not really created some things on the console, you will not understand certain things that we have defined in this particular configuration. Because on the console, when you're creating any resource on the console, there are attributes that you have to pass in. There are values you have to supply, all right, when you are creating some of these resources. Is that okay? So, when you are creating any resource using the resource block, you are basically supplying some values. So you're putting in some inputs. For example, my load balancer should have a name, so I'm passing in a name. My load balancer should have, I should choose, has this option, whether it should be internal or internet facing. In my case, I am saying internal is equal to false, which tells Terraform that I am creating a load balancer that is what? That is internet facing. All right. Now, the load balancer type, I'm using a variable here. Of course, the load balancer type can either be an application load balancer, it can be a network load balancer, it can be a GLB, it can be a classic load balancer, which has actually been deprecated. All right. So you need to specify the load balancer type. Now, all of the var that you see here, var.load balancer type, it's basically a variable reference, which means I am not putting the values directly here. Rather, I am managing all the values as what? As a variable. So here, if you come here to the variable section, you can see all of the variables that we have defined. So there's the variable for the project name, the environment, the load balancer type, the VPC ID, the subnet ID, and then the security group. Now, one thing that you will also notice here is that the variable.tf only contains the variables that we want to make use of. It does not contain the values for this variable. Okay, because in Terraform, your variable.tf file can contain the variables that you want to declare. And then you can have another file called the terraform.tf that actually supplies the value for all of this defined variable. So what I am doing here is that my variable.tf basically just contains the variables that I have defined that I want to use within, all right, my resource block, okay, and all of that. So that is what the variable.tf contains. Now, if you look at this child module, this ALB child module, one of the things that you realize here is that it does not contain a terraform.tf verse. And that is because it is not necessary. Okay, my terraform.tf verse can actually be, all right, in the root module, and then all the values for all of the modules that I'm creating can be applied, all right, in the terraform.tf verse. The only thing that my child modules need to contain is the variable.tf, because all of the modules would not have the same variables declared or defined. So the variables that I'm going to need for ALB will be different from the one I'm going to need for ASG, will be different from the one I'm going to need for my EFS, will be different from the one I'm going to need for my VPC. Okay, so that is why each of your child module will have its own variable definition. All right, they can't all contain the same variables definition. Is that all right? So if I go back to my main.tf, I can see that my load balancer, my security group, my subnet ID, all of these things are what are variables. Now, by the time we get to the root module where we have the main.tf, you would also realize that there are certain variables that we have defined here that their values are not in the terraform.tf verse. All right? Their values are basically, sourced from the output of another module. Is that okay? For example, the subnet IDs, the values for the subnet are not defined in the terraform.tf verse. Okay, if I come to terraform.tf verse, the only thing that I can see here is what is VPC CIDR block. I can't see anything like subnet IDs and all of that right here. Okay, so that tells you that not all of the variables that you have defined or that you have declared, not all of those variables will have their values defined inside of the terraform.tf verse, particularly when you are dealing with modules. Because in this case, one module's output is going to be the input for another module in this case. So our network module is going to generate for us subnet, and of course, is going to output for us subnet IDs. All right, and the subnet IDs that our network module will generate for us will serve as input for a ALB, for the EC2 instance, for the ASG, for the EFS, for the instance connect endpoint, for the database, and for all of these things. Okay, so all of the variables that we have defined here, not all of them, we're not going to supply values for all of them in the terraform.tf verse. Like I said, some of them are going to get their values from the outputs of another module. Okay, so we have all of this. Now we have a tag. So basically, a tag is a way to identify your resource, in AWS. Now, another thing that you also have to create, when you are creating a load balancer on AWS on the console, right, you start by, specifying the load balancer, whether it is internet facing or internal, all those kind of things, you define all of that. The next thing you also define, if you have done all of these things on the console, is your target group. Because your target group is basically where you will now select the instances that you want to manage, that you want the load balancer to direct traffic to. Okay, so you need to create what? A target group. Now, this target group also, you need to define, the port number, the protocol, the VPC, and all those kind of things. And of course, you also need to define the L checks. All right, because the application that is running on the EC2 instance that you want to, register with your target group, this application is actually reachable on a particular port. So in our own case, the application is reachable on port 80, which is the WordPress port. All right, and of course, which is the default HTTP port. All right, so in order for our load balancer to be able to reach these instances, it means that the application itself that is running on our EC2 instance, right, it's reachable on a particular port. All right, and that also means that whatever security group that we're going to be attaching to our instance must allow that port, right, must allow traffic inbound from the load balancer to that particular port. So here we have port 80, and we have the protocol as HTTP. And then, of course, we need to specify the VPC ID. So here we're doing what? var.vpc ID. We also have the L check defined, because the purpose of the L check here is that the load balancer would want to send traffic to instances that are healthy. So instances that are not healthy, the load balancer will not send traffic to it. So at intervals, your load balancer performs some kind of L check to be sure that the instances that are registered in its target group are actually reachable. So it performs this L check at intervals, right? At intervals, it performs this L check. Okay. Now, another thing that you also configure when you're creating your load balancer on AWS is that you also have to define a listener. All right, very important. You need to define a listener. And if you look at what we have here, we have the load balancer, ARN, and of course, we are specifying the load balancer that we have created right here, AWS ALB main, and then right here, we specify that. Okay, because the listener is also part of the attributes, okay, or part of the resources that will be created as part of the load balancer. Okay, so the load balancer is listening on what? It's listening on port 80. All right, so anybody that wants to access your resources will be on port 80. So the load balancer gets the traffic on port 80 and then directs that, all right, to your target group. And that is why if you look at this configuration, right, the port is 80, the protocol is HTTP, and the default action is that it will forward. All right. So when somebody is trying to access your load balancer on port 80, it basically takes that traffic and then it directs that traffic to what? To the target group. And then whatever it is that the EC2 instance, serves as the response to the request, then the load balancer makes that available to the end user. Is that okay? So all of these things that we have defined here will make a lot of sense if you have done these things before on the console. And that is why I always advocate that do not get into Terraform or any infrastructure as code tool if you have not done a number of things already on the console. Because when you have done a number of things already on the console, using infrastructure as code tool becomes easier. All right, so that is that for the ALB. Now, the ALB also will give us some outputs, right? So part of the output that we want the ALB to generate is the DNS, because we want to be able to access our instances using the load balancer's DNS. Right, so we're not going to be accessing it using the individual EC2 instance, public IP and all of that. And anyways, our instance do not even have a public IP. So the only way we can access our instance is through the ALB DNS, all right, endpoint. So we need to output that particular value as well. So here we have the output, the name of the output, and then the value, which is basically referencing the resource that created, the load balancer. So in Terraform, in your main.tf file, whatever it is you're doing there is what is the input. So you are imputing values for the attributes, right? The output here is basically that after Terraform has created the resources, there are certain attributes that also are generated as a form of output. And these outputs are not, you don't supply the values. They are basically a result of the fact that a resource has been created and then that resource generated some values that you can also leverage, that you can also use to access the resource maybe later in the future. Is that okay? So that is what the output here is giving us. And of course, if you go to the Terraform documentation page, you can also find some of these things right there. So if I go here, for example, and I scroll down, it gives me some argument reference, right? So these are resource all right, that I can create. And these are the arguments that I can pass into this resource. So if I want to create an AWS EC2 instance, these are arguments that I can pass in as inputs. All right, the availability zone, the AMI that I want to use, all of these things are inputs. Okay. Now, if you scroll down, all right, I mean, all of these things are just input. If you scroll all the way down, all right, if you scroll all the way down, I want to show you something. All right, if you scroll all the way down, it gives you something here. It says this resource exports the following attributes in addition to the argument above. So all of the arguments that you see above are basically inputs that you supply based on the kind of instance you want to create, right? Now, all of these other ones that you see here, all these other attribute reference are basically, the exports, the values that are auto-generated by the instance that you have created, okay? So these are all of them. So for example, now, if I need the ARN of my instance, I can also do an output for that, all right, for the ARN. If I need the ID of my instance, I can also do what? I can also do an output for the ID of the instance. So these are the things that are exported after the resource has been created. And in our own case, we're going to be seeing that the output of one resource can also serve as what? As input for another resource. Is that okay? All right. So now let's go back to what we're talking about. So that is that for the ALB. Now for the ASG, which is the auto-scaling group, now we even have some, some other things that we're going to be creating also for the auto-scaling group. All right. Now here, if you look at the auto-scaling group, we have, some additional file. Apart from the main, the output, and the variable, we also have local, we have data, and then we have another folder inside of that, which is the script folder. All right, but before I explain the ASG, let me just explain the EC2, first of all. Now, if you look at the EC2, we have main, output variable, we have local, we have IAM, we have data, and we have script. Now, what's the purpose of all of this? Now, if I go back to the architecture, I remember that we talked about the fact that we're going to create an IAM role, and our EC2 instance will assume the role because we want to be able to interact with the database, with Secret Manager, and of course the file system. And the reason is because the script that we want to run on this instance as a user data script, the script needs to do some AWS CLI command have to be carried out in order to get some values from the database, from Secret Manager, and from EFS. All right. And that is the reason why we need an IAM role that we can attach to our EC2 instance. Is that okay? Now, if you come here to the EC2, of course, we have our regular main.tf that basically helps us to create an AWS instance, WordPress, and all of that, right? But then we also have the IAM and we have the data. So let me start from the data, all right, the TF. Now, if you look at this data.tf, we are querying AWS, all right, for a particular AMI based on our region. And then we are also using a filter to basically give AWS an idea of the kind of AMI that we are looking for. Okay. Now, one thing I want to point out here is that this filter is very important, particularly when you're trying to get an AMI. It is of utmost importance. All right. Now, if you look at the filter that I'm using here, I am using, AL 2023-AMI-2023. Now, if I remove this 2023 that I have right here and I leave it like this, now it is going to generate an AMI for me. It's going to find an AMI that matches this filter. All right. But the problem is that in my research, that AMI is not going to work for our use case, because that AMI belongs to an AMI that is useful when you are running an ECS cluster. All right. And we are not running an ECS cluster here. We're deploying directly to an EC2 instance. So that tells you that there is an AMI that you can use, all right, on your EC2 instance that will serve your purpose. And there's also an AMI that can run within your ECS cluster on your instances that you attach to your ECS cluster that will also deliver, all right, what you want. So that means you have to know exactly how to, structure, all right, your filter expression. Very important. So that is why the 2023 is very important, so that we get the accurate AMI that will work for our own use case. Now, with this data block, I'm basically creating the AWS environment, and then I need an AMI that I can use, all right, to create my EC2 instance. Is that okay? Because I don't want to hard code my AMI value. Because tomorrow, what if I change my region to maybe EU West 1, to maybe US East 1? I want those things to be generated automatically, right? I don't want to hard code anything. Okay? So that is the purpose of this particular data block. Now, in addition to that, I told us our EC2 instance is going to assume a role, all right? And so here, we're also creating AWS environment, all right, to basically leverage the STS assume rule. And the service that wants to assume that, all right, is the EC2, all right, service. Okay. Now, we also have a policy document that we're also getting from AWS, all right? And then the actions that we want our role to assume, or the actions that we want, the EC2 instance. By the time the EC2 instance assumes the role, these are the actions we want the EC2 instance to be able to do. So we are not given the EC2 instance, latitude to do anything with any of the AWS services in our environment, but we are basically restricting the actions of this role, all right, to these things, because these are the services that we want our EC2 instance to be able to interact with. And the actions are, number one, the Elastic File System, the Scribe File System, RDS, and of course, Secret Manager. And if you look at it, it is basically get and then list, all right, permissions that we have here, okay? We don't have any kind of write permissions. It's basically list. Describe is maybe, to list something, to get something. The get secret values to get something. Describe is to list something. Describe your DB instances also to list, your database instances and all of that. Okay. And right here, we are also trying to limit it to, particular resource and a region. So here, I'm putting in my EOS2 region right here. And of course, I'm also putting my account ID right here. Okay. And I'm also saying that, any secret created in this account, all right, in the EUS2 region is what I want to access. So which means if I have a secret created in EUS1 region, even if it's the same account, this particular action, all right, that I'm going to be attaching to my EC2 instance, my EC2 instance will not be able to perform that if it is another region. So I have restricted, all right, what my EC2 instance can do. I have restricted that to the EUS2 region. So the EC2 instance, by the time it assumes this role, can get secret, all right, in the EUS2 region. If there's any secret available, if there's any database available, it can describe the database instance and do all of these things. Is that okay? So that is what this is about. All right. And then here also, this is to get your caller identity, just to get your ID, right? Your account ID. That's what this is about. All right. So I just decided to add this there, but I'll show you what we'll do with this later. Now, if I click on IAM, I can now see that now, because I have my data.tf, in a particular file separately, now it is easier for me to now reference all of those things that I've defined in the data.tf in my IAM folder, because the IAM file is basically going to be creating, all right, the IAM resource for us. Okay, creating the role, attaching the policy, the instance profile, and all those kind of things. So if you look at what I have here, I have my resource, and of course it is AWS IAM role, the name of the role. All right, and this is a logical name rather. And then here you have the name of the role, and of course we're using some variable there, so that'll be WordPress-EC2 role. And then we're also doing some assume role policy, and then we are getting that value from this guy, so which is data.aws blah 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 and all of that. So you can see the benefit of actually logically separating our configuration, because now I have my data.tf. So if anything changes about this policy, all I need to do is to come right here, all right, and then change whatever it is I want to change, and this will just remain the way it is. So I don't really have to manage anything right here. Okay, that is the purpose of separating all of the configurations. Is that okay? Now, another thing here also is that, of course, we have the AWS IAM policy, and then, of course, the name is this, and then the policy that we're also attaching is the data AWS _IAM policy document and all of that, which is what we have right here. Okay, so what we're doing here is we are basically attaching that policy document, all right, to this particular resource. And then here, we're also doing some kind of attachment. So the role and then the policy. Okay, so we're basically attaching that, the role and then the policy. And then the instance profile, because we're dealing with an EC2 instance. So your EC2 instance will usually assume a role in the form of an instance profile. All right, so we need to also create that resource so that our EC2 instance can connect, all right, to that. So we have the resource, IAM instance profile, the name, all right, and then the role that the instance profile is going to assume. I mean, the role is what we have created earlier, right? AWS IAM role WordPress name, which is this one right here. Where's that role? Yeah, so this is the role right here. Okay, this is the role that I've created right here, and that's what we have. All right here. So, and this is for the EC2 instance. All right. Now, that is for the IAM. Okay. Now, all of these things, like I said earlier, will make sense if you have done these things on the console. All right. I won't advise, if you have not done all of these things before on the console, I will advise you take your time to go through some of the videos I've already done on the IAM, on all of these things, and how to do these things on the console, because it will really help you to understand exactly what you see on my screen right now. Okay, if you've not done all of these things on the console before, I implore you, I'm going to link, all the series I've done on, IAM, on AWS and all of that. I'm going to link it in this video. All right, it's going to be in the description. Okay, you can leverage that, go through those videos, try to do those things on the console, try to understand all of these things on the console. And then by the time you now come back to the Terraform configuration file, it makes a lot more sense. All right, you know exactly what you're doing. But if you have not done it on the console, all of this will just look like gibberish to you. Okay, so let me make that clear. Now, we also have the local.tf. Now, the purpose of the local.tf, it's basically to, execute some kind of script in our environment. And of course, the local is actually just local to this particular module. All right, it's usable within this EC2, all right, module that I have created. Okay, and of course, it's also a kind of variable that you can also define and then, reference it within your environment, within the EC2 module. All right, you can do that. So if you look at the local is basically creating a variable, and the name of the variable is EC2 user data script. And of course, we're using a template file to read the script that we have right here, right? So we're reading this particular script. And of course, the reason why we're also using the locals is because it is easier for us to use that and then use the local to basically pass in our user data script. Because like I told you, we're going to be running the script as a user data. These are scripts that we're going to be running, all right, as user data. And of course, I will try to do a very quick walkthrough of this script and what it does. It's a shell script. All right, we're going to be running this on our EC2 instance as user data script. We actually have two of them. All right, now this is the script that we use for the WordPress deployment that we did, some days or some months back. All right, but the only thing that is different now is that we are deploying the same thing with Terraform, and of course through the GitLab CICD. All right, so we had to improve upon the script, because the script that we use for the one we did on the console is not going to work with, all right, the Terraform deployment that we're trying to do and with GitLab CI/CD that we're trying to do. So we had to make some improvement on the script. Is that okay? So that is what this local is also helping us to deploy. All right, because now if you go to the main.tf, you're going to see the local being referenced right here. So we have local.ec2 user data script, which is exactly, all right, the variable name that we have right here. Okay. All right. So, and then we are also doing base64 encode with that. So if you look at the resource, this is the instance WordPress, the AMI, this is the AMI. I mean, we're getting that from the data block right here. All right. We're getting that from the data block. All right. And then the instance type, getting that from the variable. And then we have the instance profile, all right, which is what we created earlier in this place that I told us about. And then the subnet ID, the VPC security group, the public IP address. All right, we have all of that. And then we have the user data, which is, of course, base64 encode, and then the local, All right, we're using that to pass in the script, all right, that we have right there. And then, of course, you have your load balancer target group attachment because you want to register this instance with the target group. All right, so that with that, you can allow your load balancer to send traffic to it once it becomes reachable and registered with the target group. All right, and of course, we specify the ports that we want to open up as well, and all of that. Now, our EC2 instance is also going to generate an output. All right, and we need it to actually generate an output because now we are going to be connecting to the EC2 instance using our instance connect endpoint. So that means we're going to be needing the instance ID in order to establish that connection. So that means our EC2 instance must also generate, all right, it must generate for us an EC2 instance ID that we can actually use, that we can copy and use to connect to our, all right, instance, just to verify if the script installed correctly and some other things that we deem necessary, all right, to verify. Is that okay? Okay. So if you click on output, you have the instance ID, and of course that is printing out aws_instance.wordpress.id. And then we have the private IP printed out. We're going to be printing that out also. And then we have the accounts ID, the AMI, the instance profile, and all of that. Right? So you can also see that we are also outputting the instance profile. And the reason why we're outputting that also is because the ASG is going to need that. All right? To know, okay, the role to attach to the EC2 instance that the ASG is going to be creating. Okay, so that's why we need to output that, all right, as well. Now, that is about the EC2 module that we have created. Now, if you go over here to the output.tf for the EC2 module, you would also find some resource that we want to export, right? Which, I mean, these are values that are generated by the resource after it has been created. And so some of these attributes, some of these exports are important because they can serve sometimes as input for another module or for another purpose. Okay, perhaps for example, when you're exporting out your load balancer DNS name, you really would want to just copy that and then paste that in your browser and do what you want to do, all right, with your load balancer and all. You don't want to go to the console to go and get that value. So we need to export out certain, all right, resource attributes. Is that okay? And so here we're exporting out the instance ID. Now, another thing that I need to mention about the export that we are doing for the child module is that this export will remain within the child module. If you want Terraform to print out this export, you know, all of these things that we're exporting, if we want Terraform to print it out for us, that means we must reference them in the root module. All right. In other words, what I am saying is that the root module must contain another output.tf file, all right, that will call this output value that we have right here defined. So whatever it is that we are printing out here, whatever it is that we are exporting inside of this child module actually remains within that module. All right. The only way to get this printed out on your terminal or exported maybe to a file within your GitLab CI/CD pipeline is that it has to also be called in the root module. Is that okay? So that means in the root module, we're going to have another output.tf file that will now call this child module, and that will allow us to be able to extract all of these values. Is that okay? But of course, the starting point is that in the child module itself, you are exporting out all of these things because that makes it easy for you to now call it in the root module or for another module to basically leverage, you know, these resources, you know, attributes that we are exporting. Is that okay? So I thought to mention that to us again. Now, here we also have the variables defined for this EC2, you know, child module. And of course, these project name environment, I mean, these are module that is common, these are variables rather, that is common to all of the modules that we are creating, right? The only one that is different here is the EC2 instance type, the subnet ID, and the security group, all right, VPC ID, region, and the target group ARN. Now, another thing that I would also like to emphasize again, which I've mentioned before, is that when you are defining or declaring variables in Terraform, particularly in a modular setting, okay? Now, all of the variables that we have defined here, not all of them, we're not going to supply values to all of them in the terraform.tf verse. All right, I need to emphasize that point again, because you might think that, all of these variables, of course, we need to assign values to them in the TF verse file, but not all of them require us to supply a value. Because some of these variables are basically going to be leveraging the output of other modules as their own inputs. Okay, so for some of them, we really do not have to explicitly define, all right, their values in the terraform.tf verse. For example, the security group's ID, right? We're not going to supply the value in terraform.tf verse because we already have a security child module that is generating an output for us that the EC2 instance can basically leverage, all right, to assign the values for the security ID that we want to use. Okay, for example, the subnet ID as well, we have a network module that is already generating for us subnet IDs, both for public and for private. Okay, so we're not going to be supplying that value in terraform.tf as we are basically going to be leveraging the outputs of the network child module, and that will serve as input for our EC2 instance as a subnet ID is concerned. Is that okay? So not all of the values that you have declared in the variable.tf, especially like I said again, in a modular setting, not all of the values, all right, not all of the variables rather that you have defined or declared in a variable.tf, not all of them would have a value assigned to them in the terraform.tf verse. Some of them are basically going to leverage their output of another module as their own input. All right, that's what they will do. Okay, so I thought to mention that to us again. Now, moving on, let's take a look at all the modules that we have here. So we have the EFS. So the EFS has the main.tf, and of course, we're declaring the resource, we're defining the resource, the file system, the name, we want to encrypt it, and of course, we're also tagging it as well. And right here, we're also specifying the mount target. Remember, I mentioned earlier, if you have not done any of these things on the console, whatever it is that we're doing now will look confusing. And that is why, again, I would like to emphasize that it is important for you to have done these things on the console before you start using infrastructure as code too. Because if you just go ahead and you're learning infrastructure as code and you can't deploy these things on the console, then you are going to have a problem at the end of the day. So the first place to start is that these things are things you have done already on the console. And that is why before I came up with this video, I made sure that we already have a video on the YouTube channel that walks us through how to do all of these things already on the console. Right? So if you understand that, if you watch that video and then you're watching this, whatever it is that we're doing here is going to make sense. All right? Compared to somebody who has not done it on the console before. Okay? Now that being said, so let's look at how we are mounting our EFS. Remember, when you're creating an EFS, first of all, you give your EFS a name and then you select some options or some attributes, and then you get to this point on the console where you now have to select, the security group that you want to use, and then the subnets that you want to also create, that you want your EFS to be available in, right? Because the EFS can be created in one zone, it can be created in all the subnets available in your region. So that makes it, that makes sure that the EFS is available in all of the availability zones in that region. So if you're deploying a resource in EUS A or EUS B or whatever, you can leverage or mount your EFS. Is that okay? And that is exactly what we're doing right here. So here we're using the function count. All right, the function count, and then we're doing what? We're trying to get the length of the subnet ID. And what we're doing here basically is I want to know how many subnets do we have in the first instance. Right, and that's why we have var or subnet ID, and then we have these, all right, what you call maybe an argument or a function or something. This is a meta argument, all right, and then there's a function. So the length here is a function. So we want to know the number of subnet IDs that we have, right? So whether it's 1 or 2 or 3 or 4 or whatever. Now, here we say file system ID. So basically we're getting the file system ID from this file system that we created earlier, right? And then the subnet ID, we're basically doing what we're doing, var.subnet ID is count.index. So which means if we have two subnet, all right, that we have created, it is basically, since we have the length already, right? So we're basically saying that the EFS, all right, file system should be available in the number of subnet that we have within our environment. And that is why we have used the count function earlier to get the length, which is basically the number of subnet IDs that we have, or the number of subnets that we have created. And then the subnet ID now is basically going to, is the EFS, right, is going to be created inside, is going to be available, right, in all of the subnet that we have. So if we have 3 subnet, our EFS can be mounted in all the 3 subnets. If we have 2 subnet, our EFS can be mounted in the 2 subnet. Is that okay? So that's why we have this count.index. And then for security group, we're basically saying var.security groups. All right. So which means all the security groups, all right, that we are going to pass in later on as inputs. Is that okay? Now the EFS also will generate some output like the EFS ID, the DNS name, and the mount target ID. All right, is that okay? So the mount target ID, and if you look at this one, we're basically trying to iterate over, maybe we have more than one ID, all right, that will be generated, but I don't think that is the case. Okay, so we can actually collapse these to just, a single ID if, that works, but we can leave it as this as well. Okay. Then the variables, the TF, of course, we have some variables defined, subnet, subnet IDs, and then security groups. Okay. So we have all of that defined. Now for the EIC, which is our Instance Connect endpoint, and the purpose of the EIC, like I mentioned earlier, is because we do not want to access our instances using SSH key. So we want to eliminate the need to create an SSH key. Rather, we want to connect to our EC2 instance using the EC2 Instance Connect endpoint, which is basically going to create an endpoint leveraging our VPC. All right, and then we're able to connect to our instance, even if the instance is in a private subnet. As long as the instance has a NAT gateway connected to its route table, then we can access our instance using the Instance Connect, EC2 Instance Connect endpoint. All right, and that is exactly what we want to do, because after we have deployed our resources, we want to connect to our EC2 instance and basically log into it and verify if the user data script actually executed as we expect. All right, and of course, like I said, we don't want to manage SSH keys, so we need to have the EC2 Instance Connect endpoint created for that particular purpose. So main.tf, that's just a simple, all right, setup. 2 things we need to define here, the subnet and of course the security group. Now, if you have watched the previous video that we did, all right, about deploying WordPress and all of that, we also created an EC2 Instance Connect endpoint on the console. All right, and of course, I'm going to link the videos, all right, in this one so that you can rewatch those, and then before you do, all right, this hands-on. Now, in that video, we were able to understand, even from the EC2 Instance Connect endpoint documentation, that for the EC2 Instance Connect endpoint, the security group would not have any ingress defined, which is the inbound rule will not be defined. The only rule that will be defined is what is the egress. Okay, for the security group that we're going to attach to the EC2 Instance Connect, all right, endpoint. So what we are going to define is the egress, not the ingress. In other words, we're going to specify the outbound rule. We're not going to declare anything at the inbound. Okay, so the egress is going to have, all right, the port is going to be port 22, but of course we're going to allow access only from the VPC, all right, from the CIDR range of our VPC. All right, that's what we're going to allow. So it's not as if we're going to allow port 22 to everybody. We're going to limit access to port 22 to our CIDR range, the VPC CIDR range. Is that okay? So that's the only thing that we're doing here. And of course, for the output, we're printing out the endpoint ARN and then the endpoint ID in case we need it. Of course, we may not need them, but of course, sometimes it's good to generate all of this output in case you need them, maybe for record keeping or for something, all right, like that. And then for the variable, we only need subnet ID and of course security group for this one. Now moving on, let's look at the network module. So let's look at the main.tf. Now here we have quite a number of things that we need to define. First of all, we are getting our availability zone using the data block. All right, and then we have the availability zones, and then we're giving it a logical name called ASIS, because again, we do not want to declare our availability zone inside of the Terraform.tf verse or as a variable. Rather, we want to fetch these availability zones from AWS based on the region that we have configured, all right, in our Terraform.tf configuration file. All right, in our own case, we're using EOS2 as our region. So AWS is going to query using the data block. Terraform is going to query our AWS environment using the data block to get the ASIS that we have in the region that we have specified. So that will eliminate the need of defining your availability zone inside of the Terraform.tf. So you can basically just query your AWS environment and get the availability zones, all right, available in the region that you have chosen. Is that okay? So here we have the resource that we want to create, which is the VPC, and the logical name here is main. And of course, we have to specify the CIDR block, of course. DNS hostname and DNS support is set to true. And then we have the tags, all right. And then, of course, we have the subnet, the public subnet. We want to create a public subnet because remember, our load balancer is going to be internet facing, all right, not internal. It's going to be what? Internet facing, which means it's going to be public. All right, so that means our load balancer will be deployed in the public subnet, not the private subnet. And since we are considering high availability, that means we will have at least a minimum of 2 zones where our resources will be created. All right, so it's not just going to be one AZ. We're going to have at least 2 AZs, so that if one AZ is down, the other AZ can still serve our client. All right, so here we have the count function again. So basically telling Terraform we're going to be creating 2 public subnets. The VPC ID, we're referencing that from here, AWS VPC.main.id, and then the CIDR block. Now here we're using another function again called the CIDR subnet. Now, another thing that we're doing here is that we are not defining or declaring our subnet IDs inside of the Terraform.tf. We are basically going to be slicing our VPC CIDR block into the number of subnets that we want. Do you understand that? Because normally what we would have done is that we'll have gone to our Terraform.tf verse right here, and then maybe go somewhere here and then declare, let's say we're going to be declaring subnet, for example, and we can come in and define our subnet as a list, right? And then I can come in and say 10.0.0 or the 1/24. That will be one subnet. I will say comma, and then here I'll define another one again. I can say 10.1 this time around .0.0/24, another subnet, and then comma again, and then I can go on like that. So for example, now this can be, let's say, my private. All right, so this can be private subnet, for example, and then again I can go here. So let's say I'm just declaring 2 of them. All right, again, I can go here now and I can copy this. All right, and then put this here and call this one, all right, my public subnet, right? Public subnet, and then I'll change this one. So this one is going to be 2, and this one is going to be what? It's going to be 3, right? And then I can do this and use that to create my subnet, right? So all I need to do is to come back to my network space here, and right here, instead of using the CIDR subnet function, all I need to do is to basically call, all right, so I can do something like this, right? So let me copy this. Let me just remove it. So I can do something like this. I can say this can be var dot maybe private subnet or something. So I can say this is private underscore subnet, for example. All right, so private underscore subnet, and then I will say I want the first element in that list. Okay, so var.private underscore subnet, well, that would give me what? That would give me, okay, that's going to give me what? The first element here, which is 10.0.0, all right, .1. Oh, sorry, I think this should be 0. Okay, so that will give me the first element right here. Is that okay? So that could have done that. But that is not an efficient way because I'm still trying to add code values here. So what we are doing is that instead of putting all of the values right here, why not, or I slice your VPC. So I know my VPC CIDR is 10.0.0/16. So from this CIDR, I can actually derive my subnet using the CIDR's function that Terraform provides. All right. So I don't have to declare the subnet CIDR range again. All I need to do is to slice, all right, this VPC CIDR CIDR range into the number of subnet that I want. Is that understood? All right. So now I'm going to just remove this and then we'll replace that thing back. All right. So the function we're using here is the CIDR subnet function. And what we are basically passing is, the way it works is that you put your string, the number of bits that you want, all right, and then the number of subnets that you want to create. All right. So let's go over this. So we have var.vpc CIDR. So that basically means our CIDR 10.0.0/16. So now how do you want to derive our subnet from this CIDR? Remember, we've said here that we are creating two public subnets, right? And so this function right here is the number. So which means we want to increase, all right, we want to increase the CIDR range by 8. So in this, for the VPC, we have /16. So we are adding 8 to that. So that means our subnet CIDR range is not going to be 16. It's going to be what? It's going to be 24. All right. That's what our CIDR range is going to be. So that means we're going to have 10.1.0.0/24 for the first subnet. And then for the second subnet, we can have something like 10.2.0.0/24, all right, for the second subnet. And then on and on like that. All right. So what you have here is basically saying that I want to increase, all right, the bits, all right, of my CIDR range by 8. So that means 16 plus 8 will give us 24. So the new bit or the new subnet mask, let's put it that way, all right, is going to be what? It's going to be 24/24, which basically is 255.255.255.255.0. Is that okay? And then count.index. So basically, I am creating two subnets because according to the count function that I have here, I specified 2. So that means it's going to give me what? 2 subnets from my VPC CIDR range. So that makes it easy. We didn't have to what? Add code all of the subnet values in the Terraform.tf. And I believe that is something that is very important for us to know. And for the availability zone as well, we are not also at coding anything. We're basically doing what? We're basically saying data, querying this data block that we define here, that availability.az.names. So the name of the availability zone, and then count.index. So count.index basically means the distinct index number starting with 0, all right, corresponding to the instance. So if there are 3, all right, availability zones, or 2 availability zones, or you can't have less than 2 availability zones, right? So what it's going to do here is, since we're creating 2 public subnet, it is going to what? Create 2, all right, subnet in 2 different availability zones. So one is going to be what? In the EU 2A, and the other will be what? In 2B, because I'm using EUS2. Okay, so that means if I increase this to 3, for example, it's going to do what? It's going to create 3 subnet, all right, 1 in each of the availability zones. And in the EUS2 region that I'm using, there are 3 availability zones. There's the 2A, 2B, and 2C. So if I specify 3, what it's going to do is that it's going to generate 3 subnets for me, all right, and then it's going to create them in 3 different availability zones. And that is what the count.index is doing right there. But then let's just limit that to 2. I hope that is understandable. Now, if you look at the tags also, we are also, using the count function here as well. The tag, so the name of the VPC that I want to create is going to be the project name, which is WordPress -public subnet -count.index.1 +1. So what do you think that would mean? Right? So the first index, then increase it by what? By 1. Is that okay? So that's exactly what we're doing right here. So we're increasing the name by, all right, by 1. So since we're creating two subnet. Okay, but of course, all of these things, by the time we apply, we do Terraform plan or Terraform apply, we can get all those values derived and then see what exactly will be applied, all right, before we hit the apply button. Okay, and then we're doing the same thing for, all right, we're doing the same thing for the private. Okay, and if you look at what we have here, we have the private subnet, and then we have the count, which is also 2. We have the VPC ID, which is also, all right, the same thing, and then we're using the same function here. All right, using the same function, and then increasing that by 8, count.index, and then we have the +2. Now, there are 2 things here. Here we didn't use the +2, but here we use the +2, but I think that is some kind of, but then let's apply it. Let's plan, let's apply, let's see what that would do, all right, for us, because it is always good to put some things in our configuration and then test it out and see what the behavior, all right, would look like. Is that okay? So let's leave it at this. I mean, that was kind of intentional, just to show us, what the behavior is. If I use count.index, what will I get? If I use count, all right, .index +2, what is going to be the difference between the two? So it's always good to, to play around with some of these things so that you can understand the behavior and what you can likely to get, all right, better. So that way, okay, if I use this, this is what I will get. If I use this, this is exactly what I will get. And in some cases also, it really doesn't make any difference. So that way, you know when to use, all right, what. So let's leave it at this, and then we'll see, all right, what we're going to get at the end of the day. Okay, but then this still remains the same. And of course, for the internet gateway, we're creating an internet gateway. And then right here, we are also creating our NAT gateway. Now, we're creating just a single NAT gateway to reduce our cost as much as possible. But of course, in some environment, you're going to have, all right, a one NAT gateway per, all right, maybe private subnet or per zone, basically. That's what you're going to have, right? But here, we want to use one NAT gateway for all of the 2 or 3 zones that we have, just to reduce our cost. But then in some environment where they have a lot of money to spare, right, they can have one NAT gateway per availability zone. I mean, that will also ensure some kind of high availability and things like that. Okay, but then we're using a single NAT gateway. And that is why here we're saying that this NAT gateway should be created inside of the first public subnet, and that's why we have the index as what? At 0. So that means this NAT gateway will be created where? Inside of the public, all right, the first public subnet, which is like the first public subnet. And then of course, when you're creating a NAT gateway on the console as well, you need to allocate an elastic IP. All right, so we're doing that also. The allocation ID equals AWS_EIP.NAT ID, which is the one that we have created right here. Okay, so we've created that right here. And additionally, we also need to create our route tables. Now, all of these things that we are doing, if we had used, all right, the Terraform module for VPC, we will not need to go through all of this configuration as so that we are going, all right, through. Is that okay? But of course, it is important for us to know how to write modules in Terraform, and now you can, use all of these resources to get, what you want. Because in some high-level environment, you are not going to be using the Terraform modules that have been predefined on the Terraform documentation page. You are going to create your own modules yourself for any resource that you want to deploy on AWS. Okay? But of course, the Terraform module that have been created already on the Terraform documentation page makes things a lot easier and all of that. But then it is also good, or a good idea, for you to know how to create your own modules and how to create your resources using the modules that you, all right, have created. All right. So here we're creating the route tables, and then of course the route table is going to assume the VPC ID, the CIDR block is going to be 000, the gateway, which is the internet gateway, and for the route table for the private subnet as well, that is also going to be assuming the NAT gateway that we have created, 00 to any other place. And of course, we need to do some route table association. So our subnet needs to be associated with the correct route table. So here we have the AWS route table association, which is for the public route table in this case. And we're associating 2 subnets to that. So the subnet ID equals to the AWS subnet dot public count.index.id. So it's going to iterate over that, and then we have 2 public subnets. So the 2 public subnets will be associated with this route table that we have tagged as the public, all right, route table. All right, and then The private route table also, we're doing the same thing, and that would also associate all of the subnet, the two subnet that we have created, that will associate it with, all right, the private route table. Is that okay? So that's what we're doing right here. And of course, we have some outputs that we're generating, the public subnet ID, the private subnet ID, the NAT gateway ID. I mean, those are the outputs that we're generating from this resource, because these two are very important, all right. And then the VPC ID is also very important, because there are other resources, other child modules that need these, all right, resources as their own inputs. Okay, if you look at the AWS subnet, we're basically trying to list, all right, the public subnet IDs. Okay, because it's not just one public subnet that we have two, all right, public subnet. So this asterisk here basically means give us all of the available public subnet, all right, that you have. And the same thing also goes for the private, all right, subnet. Okay, and then for the RDS, we have the main.tf, and of course, we need to, when you're creating a database on AWS, if you've done it on the console before, you know that the first thing you need to do is to create what you call a subnet group. Is that okay? So the subnet group, what's the purpose of the subnet group? The purpose of the subnet group basically is to help you, all right, create more like a list of subnets, let me put it that way, that you're going to create your database, all right, on. Okay, so you're basically saying my database is going to be created on this particular subnet. So you create a group and then you put maybe 2 or 3 subnets depending on, the kind of database you're trying to create. You put all of the subnet together, and then by the time you're creating your database, you're now specifying that the database should be created in this subnet group, which is actually a very mandatory requirement, all right, for database on AWS, all right, S. Is that okay? And then after you have done that, then you now define your DB instance. So the database instance that you want to create. So we have the database identifier, which is basically more like the name of your EC2 instance. Okay. And then we have the engine. So you can see that all of these are variables. Now, all this DB engine, the engine version, the DB instance class, the storage type, the DB name, the DB username, all of these are variables that have values inside of the Terraform.ta verse. Right? The value to these variables is not coming from another module. It is basically defined inside of the Terraform.tf verse. Is that okay? So we are going to supply all of these values. And then here we have the publicly accessible, of course, that'll be false. We don't want it to be publicly accessible. And then, of course, we have the manage master user password equals true. So what that would do is that the password for the database will be generated by RDS and stored in Secrets Manager. And that is why in the architecture that I showed us, that is the purpose the Secret Manager is serving. All right, the Secret Manager is going to hold, all right, the password to our database. And that is the reason why we have this manage master password equals to true. So the password will be generated and stored inside of Secret Manager. Skip final snapshot equals to true, so that when we delete these resources, it does not create, all right, any snapshot. Because if it does create a snapshot, then we're going to accrue a cost for saving those snapshots. So we don't want that to happen. So the moment we delete all these resources, we want the snapshot to also be deleted. We don't want to create any, all right, snapshot. And then for the security group, we're referencing the security group that will be generated by the security group child module. And then the DB subnet group name, we're basically referencing this subnet group that we have created, all right, earlier is what we're referencing right here. And then we have the tags, basically giving our RDS, all right, an identifier. So for the output, we have just the RDS endpoint. So the RDS endpoint is the only thing that we are outputting here. And that's what we really need, all right, to output. And then for the variable, we have all of this DB name, username, engine, all of those other stuff. Now for security, we have the main.tf, all right. So here we're defining all our security groups. So, one of the advantages of using module is that you can logically separate, all of your resources, and then you can also reference them, all right, if you want to. So here we have the AWS security group, and the first security group we are creating is for the EC2. All right, and the security group, the EC2 security group is also what our auto-scaling group will also leverage as well. So here we have the ingress, all right, 80, port 80 to port 80, the protocol is TCP, and we're allowing access to that port, all right, from the application load balancer security group. The same thing for 443, and then for the ingress for port 22, we are allowing access, all right, from the security group of the Elastic of the EC2 instance connect endpoint. And then for egress, of course, that should have, that should be should be allowed out anyways. Now, this is the security group for our instance, EC2 instance connect endpoint. And for the egress, we have 2222 opened up, and then of course, we are allowing that from the CIDR of our VPC. So which means not just from anywhere, but it has to be from where? From the CIDR of our VPC. And of course, we have the tags. Now, for the EFS, of course, we have to allow port 2049, which is the NFS protocol port. The protocol is TCP, and the security group is what? Is EC2. So which means we're allowing our EC2 security group to access our EFS on this particular port number. And the self here, which is true, basically means that this security group should also reference itself. All right. So that means we're going to have two ingress rules. One that allows the EC2 security group to access our EFS, all right, file system. And the other one that allows the EFS file system to also allow traffic from itself. And that is why this self is equal to true. Because instead of defining an ingress and then referencing the EFS security group itself, we basically just use the self, all right, keyword, and we set that to true. So basically we're telling Terraform this security group should also create another ingress that will reference itself. All right. So that is what this is about. And the RDS also, we are opening up port 3306, and we're allowing access to that from the security group of the EC2, all right, instance. Okay. And then for the ALB, we are opening up port 80 and 443, and that is allowing access from anywhere. So anybody can access it because our load balancer actually is public facing, all right, or internet facing, which means it should be accessible from anywhere. All right. So we have that as well. And that is all that there is to the security group. And of course, the security group is going to produce output for each of the security group that we have created, because this security group will serve as what? As input for your EC2, for your ASG, for your RDS, and other resources that we want to create for the EFS and others. So we need to output or export, all right, all of these resource attributes that have been created by these, all right, security group. Good. And then of course we have all the variables defined right here. Now, we have created all of these child modules. So the question is, what then do we need to do next? How do we now create all of these resources? Now, in Terraform, regardless of the number of child modules that you have, in your root module, you still need to have your main.tf file in your root module. So if I click on main.tf, all right, I can see here I'm defining my provider as AWS, and then of course my region is, all right, has been, we're using variable. Now, all of the modules are being defined right here, or the modules are being called right here. Is that okay? We're now calling all of the modules that we have created. So even if you have 100 modules, even if you have 30 modules, you must still call all of the modules in your main.tf, all right, file. So module, network, and then we specify the source. So the source for this one is, all right, /. So here we are calling the modules that we have created, all the child modules. And in your main.tf file, you have to call each of the modules, because you don't have to change directory to the module folder and then run your Terraform apply one by one. No. All right, so you can be in your root directory and then do your Terraform plan, do your Terraform apply, and you're good to go. Is that okay? So in your main.tf, which is outside of the module directory, you are now going to be calling out, all right, all the modules that you have created in the modules folder. And the way Terraform also works is that when you create modules like that, you do your Terraform init. So which means if I had another module here now, I need to run my Terraform init again so that Terraform can initialize that module. Okay, so here I'm calling out my network, all right, module, and I'm specifying the source. So the source is ./module/network. And the default route, which are basically all the variables that I have declared inside of that child module. So those are the variables that I'm referencing here, right? If you look at the network module, there are variables that we define, right? Environment, for example, I think environment is one of them. Default route is one of them. All right, environment again, and then I think that's about it, right? So environment, and then maybe the project name or something, right? The project name also. Okay, so if you look at the main.tf, those are basically the variables that we are assigning, that we are also spelling out here. Okay, so which means every variable that you declare, that you use in your child module, you must come here and also declare the same and also reference them, whether it's variable or you want to assign a number or a value or whatever it is. I mean, here is where you now supply the inputs. Is that okay? So we are calling them out from here. So we do the same thing for EIC. So all of the variables that we have defined, we basically also bring them here and also, you know, use the same variable var.whatever. And basically now at this point here, this is serving as the input, all right, for that variable. Is that okay? So all of this that we're defining here now is not standing as what? As input for those variables. Is that okay? So if you look at the subnet ID now, it's saying module.network. So basically this is referencing what? The network module. Module.what.network.private_subnet_ID, and then I'm interested in what? In the first element, all right, in that output. Now, the reason why we're able to reference this is because the network module gave us, all right, some output that is serving as input for the EIC module. If you go back to the network guy, if you go to output, you can see you have private subnet IDs and the public subnet IDs. So the network module is generating an output that our EIC module can use as its own input. Is that okay? So if you go back here now, you have the subnet ID, and then you have module dot the network, which is the name of the module, and then the output, all right, name. If you go back to the output, you definitely see what? Private_subnet_ID. So it is the output that network module has generated that the EIC is now leveraging as its own input. Is that okay? And then of course, we are saying that we want, the first item. So which means this EIC module is going to be created inside of the first private subnet. And then for security group also, we're doing the same thing. So module dot the name of the module, which is security group, and then the output, EIC_SG_ID. So if you go to security and you go to output, you are basically referencing, all right, these particular, all right, outputs. This is what you're referencing. Is that okay? So it is basically referencing, all right, the outputs that this security module has generated for us. So that is what we have here as module.security.eic_sg_id. Okay. So same thing for the security module, all of the variables we have defined will come here, and then we pass in the values, all right, to them. So the VPC ID, for example, module.network.vpc_ID. So if you go to the output of the network module, you are going to see VPC ID right here. So that is what this guy is leveraging. So the same thing for your EC2 instance, you have that. Now, another thing here that is different is that we have the depends on. And the reason why we have the depends on is that we want it that the database has been created first before the EC2 instance is created. Because the EC2 instance is going to run a script that needs, all right, to interact with the database. All right, so we don't want an issue where the EC2 instance has been created and then maybe the database is still creating and then the script will fail to run because the database is not yet created. So that's why we have what? It depends on. And we're basically saying it depends on what? It depends on the RDS module. So which means after the RDS module has been created successfully, that is when the EC2 instance module will now create its resources. All right, so that's what we have here. And then you can see here the VPC, we have module.network, so referencing the output, all right, from the network module. And then subnet ID referencing the output also from that, space. So here we can say we're using once, which is the second element, all right, in that list. So we can change this one to 0, so referencing the first element in that list. And then for security group also, we're referencing the EC2 SGID security group, which is an output from the security, all right, module. And then the target group ARN, we're also referencing an output from, all right, the ALB, all right, itself. So module.alb dot, my name of the output, and then the EC2 instance type. Now, all of these ones that just have var dots, they are the ones that have their values defined in the Terraform.tf verse. So don't make that mistake. So the ones you see here that has var.ec2 instance type, var.this, var.that, those are the ones that have their value already defined inside of the Terraform.tf verse. So, but all these ones that have modules dot, those are the ones that are deriving their value from the output of another module. Okay, so the var dot, those are the ones that you have the values already defined inside of your Terraform.tf verse, while the one that have the module dot are the ones that, all right, have their input sourced from the output of another module. Is that okay? So let's take note. So here again, we have for the EFS also, we are calling it out, the project names, the project ID, the subnet IDs, and then the security group. So here, we're not slicing the subnet, right? We're basically leveraging all of the subnets. So that's why we don't have any, any kind of list here. So it's basically taking the whole object, all right? So it's taking the whole thing. And then for security group, of course, we're referencing just one security group. And then for the RDS also, we can see what we have here. So for RDS, majority of them, we have the var dot, which means all of these have their values already defined in the Terraform.tf verse file. But the ones with module, like I said, they are sourcing their IDs from, all right, the output of another, all right, module. And then the ALB also, we have the vars, all of these also all these vars are basically defined already in the Terraform.tf verse, while the one that would module are basically sourcing their input from the output of another, all right, another module, okay? And then we have the ASG, which is the auto-scaling group. So that one also depends on the EC2, which means we want the EC2 to have been created and then executed some script for us beforehand, before the ASG instances are created. Because the script that will run on the ASG instances is different from the script that the EC2 instance is running. The script the EC2 instance is running is more like the initial script that was do all the setup for us. The script that the ASG instance is running is basically to mount the EFS and nothing more. All right, so that's why we're saying this also depends on the EC2. So after the EC2 has been created, then the auto-scaling group instances will also, all right, get created. Okay, and so we can see all of these: desired capacity, minimum, maximum size, period name. So all of these are defined already in the Terraform.tf verse, and all these ones are basically, all right, leveraging the output of another module. Is that okay? So that's what you have. Then you have the output. So all of these outputs now are the outputs that will be printed out on the console. If you look at all of this output, we have module dot. So basically, we are calling the output of these, all right, of the child modules. Now, not all of them. We're not printing out all the output that the child module is already exporting. We're not printing out all of that. But there are some specific outputs that the child modules, all right, are exporting already. And we need those values, all right, printed out on the console, or even maybe saved as text or something. And one of them is the DNS of the load balancer. So basically, the child module is already exporting that. And then we are basically now calling that again in the root module so that it can be printed on the console. Because all of the output that you have defined here, if you're not calling them in the root module, then it's not going to be printed out on your console. It is only useful at best by other modules that need their values as inputs. But for you to get it printed out on your console, you need to also define output.tf in the root module, and then you now use that to call out, all right, all the exported, attributes of these resources. So we have the DNS name, the account ID, the EC2 instance ID, the Amazon AMI ID, and then the instance IDs for the auto-scaling group. Is that okay? So, and then for the Terraform.tf, we already have the required providers, we have the source, the required version, and then of course we have the bucket as what do you call it now? We have a bucket already that we want to use as our backend. So we're not going to be using a local backend. We're going to be using S3 bucket as our backend. All right. And then, of course, we're going to be locking the state of Terraform using the DynamoDB so that when we're running any Terraform apply command and all of that, the state is locked so that anybody that is trying to do the same thing at that particular time, Terraform will not allow that until we are done with what we're doing and then the state lock is released. Then other people can do their apply and all of that. Is that okay? So I'm going to change this key name to Terraform WordPress. All right, let me just say YT. For YouTube. Okay, and then we have the Terraform.tf. So all of those variables that we saw in the root module that have var.var. This is where their values, all right, are defined. So the region, the project name, the environment, the VPC the default route, the load balancer type, the EC2 instance type, the ALB instance type, the database values, all right, and then the ASG minimum, maximum, and desired, all right, capacity. All of them have been defined right here. Now, another thing I need to call your attention to is that now in the root module, we also have the variables.tf. Now, any variable that you declare in your child module that has its value sourced from the Terraform.tf verse, right? That same variable must also be declared in the root module. Let me repeat that again. Any variable that you declare in your child module, all right, that sources its value from the Terraform.tf verse file, that variable must also be declared in the variable.tf in the root module. I hope you understand that. So if you look at all the modules that we have, they all have their variables.tf. So the idea is that every variable that you have in the child module, okay, particularly the ones that are going to source their value from the Terraform.tf verse file, these variables must also be declared in the variables.tf in the root module. The only variables that you use in the child module that you do not have to declare in the variable.tf in the root module are the variables that are sourcing their values from the output of another module. Because those values are not predetermined, they are not known. They have to be computed by that other module, and then it generates an ID that, all right, your own module can now use, or the other child modules can use. So to take that again, any variable that you declare in your child module that is going to source its value from Terraform.tf verse file must also have the same variable declared in the variable.tf in the root module. All right? But any variable that you declare that is not going to source its value from the Terraform.tf, but is going to source its own value from the output of another module, then you don't have to declare such variable in, all right, your variable.tf that you have in the root module. Okay, it's as simple as that. So now we are done with explaining all of these Terraform configuration. Of course, there are a little modifications that we can do, but I have left some of these things here as is because I want anyone that will also do this hands-on, I want you to rework whatever it is I have done. Okay, there are certain things that can be done better here, but intentionally I left it because I want you to expand on this. I don't want you to take this and just do it and just apply the way I've done it. I want you to look at this thing that I have done and see ways by which you can improve upon it and make it better. All right, that way you are going to be learning that way. But if you only apply the things that I have done and then you are replicating it, you are not going to be learning much. But take a look at what I have done and then look at how you can improve upon the configuration files and see that, oh, okay, instead of this person doing this and doing that, why not I consolidate this and this into this place and then do it like this? So that way you are going to be learning. Because if you're just going to be replicating what I have done, you're not going to be learning much. The only way you would learn is to look at what I have done and then find, ways to improve upon the things that I have done. That way you are going to learn. And that is what I expect you, to do. Now, coming to the GitLab, that we want to use, because we're going to be deploying it through the GitLab pipeline. We don't want to do any Terraform local apply here. We don't want to do that. I mean, we are in an organization, and of course, we run our Terraform configuration through the pipeline. That is using the GitOps principle. Okay, so we're not going to be doing Terraform apply, Terraform plan. Everything is going to be done through the pipeline. Now, in the last video that I uploaded last year, I talked about a secure way by which you can access your AWS environment using what you call the web identity. And by using the OIDC, which is OpenID Connect. And I showed us an example of how you can use GitLab, to do that. Basically, how GitLab can assume a role on your behalf and talk to AWS, and deploy resources on your behalf without you provisioning an access key and a secret key. I'll also put that video, in this particular one. I will link it up here so that you can watch that video again and understand what we want to do. Is that okay? So I remember I mentioned that in that video. Okay, so go and watch it so that you understand what we're about to do now with the pipeline. So now here we have our stages defined. Now, if you're not familiar with GitLab, I have a dedicated playlist, a 0 to Hero series on GitLab CICD. I'll also link the link to that playlist in this video as well. So do well to watch it and do yourself, some good. Okay, because I'm not going to be walking you through all of these things that we have in the pipeline, because I already did that in that 0 to Hero series. So I'm not going to be explaining, all of what I have right here, but just a few things to help our understanding. So here I'm defining this image globally. So that's the image that I want to use, because what I want to deploy is Terraform, and I'm doing that through the GitLab CI/CD pipeline. Okay, so I'm declaring the global variable, that I'm using HashiCorp Terraform 1.10, version. That's the image that I want to use. Since GitLab uses Docker out of the box. Now here we are going to be creating a DynamoDB table that will help us to lock, our Terraform sessions, or Terraform states. So the first thing we have here is the state lock, and then the stage is Dynamo. And of course, we have all these ID tokens and all of that. Like I said, in the last video that I uploaded on the YouTube channel, I explained clearly, this web identity with OIDC with GitLab. So I'm going to link the video. Do yourself a favor to watch that to understand exactly what this is doing. And here I am overriding the default image that I have set here to basically say this particular stage is going to run with the Amazon, Docker image. And of course, I'm overriding the entry point as well so that I can pass in my own commands. Okay. So here, of course, I need to do all of this so that my GitLab can obtain, a short-lived token that would allow it to be able to create resources within my AWS environment. And that is the purpose of this. So in that video also, I explained what all of this is and how you can get all of these values. So I'm not going to go into details in this video. So here, this is the script that we want to run. So this script is basically going to do something for us. Now, the first thing it's going to do is to check our environment to see if we have any DynamoDB table already created by this name. So if there's any DynamoDB already created with this name, it's going to skip the DynamoDB creation. That's what's going to happen. But then if there's no table with this name already, then it's going to go ahead and create this DynamoDB using the AWS CLI, command. So AWS DynamoDB create table, the name of the table, and then other information that are, necessary. Okay, so that is for creating the table. The next thing here is that, of course, we have to do Terraform init. We have to initialize our Terraform configuration. Is that okay? So we have the Terraform init, and then the stage, of course, is init. And since we are using the the HashiCorp image for this one, we're not overriding the image. We need to have AWS CLI installed inside of that image, because here we're going to be running some AWS command as well to obtain the short-lived token that is needed. Is that okay? And then that is also going to happen in the before script session. And right here, we have the script. So the script basically is to do what? Terraform init. We're initializing Terraform configuration. And when you run Terraform init, it produces like two things, the .terraform folder and then the Terraform log file. So we need to archive those two things so that other stages can leverage that. So that, they don't have to do Terraform init for each of the stages. So they can basically leverage this artifact and know already that, the Terraform has been initialized already. These are the details. This is the provider. These are the things that we need to work with. And then they can go ahead and do whatever it is that they have to do. Okay, so we're specifying, so for validate now, we're specifying the same heading. So the purpose of validate here is to basically do Terraform validate and to do some FMT check. So the FMT check here is going to check our Terraform configuration, the semantics, the correctness, the alignment of your Terraform code. That's what the Terraform FMT is going to check. And then Terraform validate is going to check the syntax, of your Terraform configuration. If some things have been declared properly, if some, maybe for example, where we have depends on, those depends on, is it not breaking anything? All the variables that we have declared, are they getting their values correctly? All those kind of things is what validate is going to check, for us. And then we move on to Terraform plan. We do the same, get token and all of that. And then we say Terraform plan out. So we're basically printing out the Terraform plan file. So the name of the Terraform plan file that we're printing out here is what is plan file. And another thing that we're also doing, because in some environment, you also want to print out or archive your Terraform plan, so that you can go through the plan before you hit the apply button. So in this case, we are also outputting the plan file in plain text, in .txt, so that it can be readable. We can look at the plan that Terraform has generated for us, and then basically look at that in the text form and see if, something needs to change or we need to work on some areas, okay? And then, of course, we are also archiving the two of them. Because we want to make it available in the pipeline for the subsequent stages. So the Terraform apply is going to be able to leverage this plan file to create our resources. Is that okay? And then, of course, the TXT also, we're also archiving that so that we can download the TXT, and then that will be in the human readable form. Okay? So we're doing all of that as well. And then we have the report, and then Terraform plan file, and then we have the apply. So here, the apply is going to do what? It's going to basically apply. Terraform apply, And so we're getting the token again, and then we say Terraform apply. The input is false because we have generated a plan file that you can actually use to create the resources. So we have that already. And then the Terraform output also, we are also outputting that in the form of text. So apart from printing it out on the console, we also want to print out all of the output into a text file that we can actually download and store somewhere or share with our colleagues. Okay, for example, the load balancers endpoint, the EC2 instance IDs and all of that. We also want to print that out and archive that as well so that we can share with our colleagues to say, this is the endpoint and all the information of the resources or infrastructure that we have just created. Okay, and we also have the artifact. So we're keeping that also as well. Now, this is going to be what? Triggered manually, because we want to check the plan file first and see that everything is in order. And then we go ahead and apply. And then we also have the destroy stage. So which is after everything is done, we can also manually trigger the deploy job, and that will destroy all of the infrastructure that we have created. So we have that also right here. Okay, so script Terraform destroy auto approve, that is also going to be triggered manually. The environment here really is not necessary, but I just thought to add it just for, for some learning. That's why I added the environment. The name is UAT, the action stop. So we're going to see all of this in action by the time we apply. When you apply things, you will understand better what, some of the commands actually what they do. Is that okay? So that is the pipeline configuration that we are going to be executing. So now I can do Git push and all of that into my environment. But I just want to show us one thing. Now, on the EC2 side of things, this is the script that we want to run on our instance as user data. And if we look at this script, just to give you a walkthrough of what the script is doing. So we have the AWS region defined. We have the DB instance identifier defined. And then we have the DB_secret_ARN also defined. Now, I told us earlier that our database is going to be auto-generating the database password, and it is going to be putting that password in Secret Manager. Now, this script is the script that we used before when we deployed, on the console. But now things have changed. We are deploying through Terraform, and we're not going to the console to do anything. Everything is going to be done through the pipeline. So that means our WordPress, remember, WordPress has a requirement. Your wp.config.php file needs to be edited, and then the values of your database, the database endpoint, the database user, the database password, the database name has to be populated. All right, hence including all of this information in the user data script so that it can do all of that for us and edit our WP config file and then help us to fill in all of these values ourselves, because we don't want to log in into the EC2 instance and then now start editing, all right, the WP config file. We want Terraform to help us do all of that, all right, by default. And so that's why we are doing all of these things. Now, an assignment that I want to give to us is, I want you to, if you're watching this video and you're doing this hands-on, I want you to take a look at the script and try to make sense of what this script is doing. Because like I said, if you're going to be doing just what I am doing, you're not going to be learning much. The beauty of learning is that you go beyond what you are being taught, and then you're finding your own way of understanding things. So the assignment I have for us is that I want you to look at the script, all right, and then make sense of what you think the script is doing. I mean, it's going to be available in my repository. You can download it, clone it. I mean, just take a look at it and try to make sense of what exactly, all right, all these things, all right, all these things, I mean, what this thing is doing. And of course, for the ASG also, we have the script as well, but that is not as robust as, for the EC2 instance. So that's just a simple thing. And then it's helping us with this. But this one is quite robust. And if you scroll down, you'll see, all right, a lot of shell scripting stuff right here. And of course, if you scroll down a bit, you can also see some kind of edits going on with the WP config file, all right, and all of that. So take a look at the script in your free time. While you're doing this, try to make sense of what exactly the script is doing. That way you will learn, all right, and be better at, doing all of these things. So guys, we've said a lot of things, and I think it's time for us to deploy and see what is going to happen. Now, last thing that I just want to talk about is, already within my VS Code, I have integrated my GitLab workflow. So the GitLab pipeline can be viewed directly from, all right, my Visual Studio Code. So I don't have to go to my GitLab environment to see, all right, what is running within my pipeline, what is going on there, and all of that. So I've integrated my GitLab, all right, with my Visual Studio Code, and I've done that using this extension called GitLab Workflow. All right, and of course, I've authenticated with, all right, GitLab. I've authenticated Visual Studio Code with my GitLab, so both of them are kind of synced together. So whatever it is that I'm doing here, I can visualize my pipeline right here in my VS Code. Okay, and that's exactly what I'm going to be doing. I'm not going to be going to my GitLab environment to see what is going on with the pipeline. I'm going to be visualizing that right here within my Visual Studio, all right, code. So guys, without any further ado, let's go ahead and create all these resources, and let's see the magic that happens. All right, so I'm going to do git, all right, commit, and then we're going to say, let's just say running WordPress pipeline, okay? And then I'm going to say git push. Okay, so the pipeline has been pushed. So guys, let us go now and see what is going on behind the scenes. Okay, so I'm going to click here, all right, and I'm going to refresh all of this, all right, and then you can see that my pipeline has actually started. So if I click here right now, I can visualize what is going on, all right, within my GitLab environment. Can you see that, guys? So if you look at it here, all of these ones are basically paused. So you can see the job succeeded. So the DynamoDB table has been created successfully. Okay, and the Terraform init job is now what? Is now running. So I can click on that again, and then I can visualize that right here within my Visual Studio Code. Isn't that interesting? All right, so I don't have to go to my GitLab environment. I can just view what is going on with my pipeline here. So if, in case I encounter any kind of error, I can see it right here and fix it, push it again, and just visualize whatever it is that is going on right here, all right, on my Visual Studio Code. Is that okay? So let's take a look at what we have. Let's just, follow what is going on with the pipeline. So the Terraform init is what is running at the moment. So let's see if that runs without any kind of issue. And as you can see from the GitLab, we're using the shared runner. We're not using our own runner, which is, it's okay for what we want to do for now. Already in the GitLab 0 to Hero series, we talked about how you can create your own runner and attach that to, your job. So the init also worked as well. So if you look at what we have here, all of the modules were initialized, right? The ALB, the network, the RDS, everything was initialized and it was successful. And then if you go back to validate now, you can also see Terraform validate. We can see what Terraform is trying to do. Alright, so it's going to try to validate, the configuration and be sure that everything is actually correct. Okay, so it's going to check that. So let's see. Alright, so that also succeeded. That's a good one. So next up is the Terraform plan. Okay, so we can click on that also and take a look at what that would also give us in terms of the planning and all of that. So let's just wait a minute and let's see what Terraform plan is going to do. All right, so we can also see that the plan job also succeeded, right? And then we can see the output. So there are 36 things to add. All right, and then we have all of these outputs that will, be generated, okay, after the plan has been applied. Can you see that? After the plan has been applied, so we can see all of these things. So you can just scroll through here from your Visual Studio Code and see exactly what Terraform is going to create after it's been created. All right, after all the resources have been created, you can have an idea of what Terraform is going to create. So we have all of that here. So if you scroll down, we have our apply job, which of course we need to trigger manually. So if we're okay with the Terraform plan, if everything is fine, we can go back to apply and basically we can trigger this job. So it says this job requires a manual action, right? So I can come in now and say trigger this manual action. And my apply job is going to, kick off. And I can see that the apply job is also running at the moment. So at this point, I'm just going to pause my screen because it's going to take maybe like 5-10 minutes for all of the resources to get created. So I'm going to pause my screen at this point and then come back when all the resources are being created. We can see that this also applied successfully. And right here, we can see all of the outputs. So I can see all the 36 outputs. I can see the ALB DNS endpoint. I can see the Amazon ID, which basically is the ID of the instance that we're using. And we can also see the EC2 instance ID, the AMI account ID, the instance ID for the ASG. So we can also see that one right here. So these are the that we have. So, and of course, we can log in into the instance using these IDs. Okay, so we can do that. All right, so we have all of that. Now let's take a look at let's log in and let's see what we have, right? So you can grab this and then you can open up this command and then you can put in your instance ID. So the command is AWS EC2 -instance -connect SSH, then the instance ID, and then you press enter. So we don't need any SSH key or anything of such. So let's see. Okay, so he's asking us, so we can say yes. And let's see if we're able to connect. So there you go. We're able to connect to our instance without needing any form of SSH key. Okay. So now if I do df -h, I can see clearly here that the EFS was mounted. And then if I do sudo systemctl status httpd, I can see that my httpd is running. And if I do sudo cat wp-config.php. Now, if I scroll all the way up, I can see that all those values were automatically supplied, right? So I can see the WordPress name, the database name, I can see the user, I can see the password, all right, automatically supplied, and I can also see the endpoint automatically supplied. So basically, that tells us that everything actually worked as expected. So right now, I can grab this. And then go over here and then put this in the browser. And then let's see what this is going to give us. And there you go. Your WordPress installation is up and running. You can do continue, or you can give your site a name. So we can just say, so let's give the site a name. All right. And then let's install. So if everything is working, if the instance is able to reach the database, then we should have the success. That means database connection and everything was done correctly. So we can do login. All right. And then there you go. You have access now to your WordPress installation, and you can go to the web page and then you can see what you have right here. All right. So that is how to deploy your WordPress site, all right, with Terraform, all right, through the GitLab CI/CD. So we didn't even apply the Terraform locally. We did that through the GitLab CI/CD. Okay. And of course, if you're interested in going to the GitLab CI/CD, particularly if you are interested in getting some of the artifacts that we exported, you can actually open up the GitLab right here, go to pipeline, and you can actually see the pipeline that we just ran. And of course, you can come right here and you can download all of the artifacts. Okay, all the artifacts are right here. And if you click here, and you can see that this was run 28 minutes ago. All right, so you can click here. All right, and then you can see all of the stuff. So right here, we can play this, run it, okay, and then destroy all of the environment. Okay, so we can do that. Okay, so I believe now we understand how to go about all of these things. How you can run, all right, your Terraform configuration through GitLab CI/CD, particularly creating resources and the integration with Visual Studio Code. Now, I want to encourage us, as many of us that will be watching this video and be doing all of this hands-on, to go beyond what you have been, what you have learned in this video. There are certain things that can be improved upon in this deployment that we have just done. And I'm giving us that as a challenge to go through this and make the script even better. All right. So let's go ahead and let's destroy. So trigger the pipeline, and of course, you can go ahead and destroy the whole, configuration.